In this problem, we have a list of non-overlapping rectangles, and we have to look at all the points that are included in those rectangles, including at the boundary. So we may have multiple rectangles like this, but none of them will overlap. And we have to consider only the integral points. So the input also will be integral points. And in the input, what you need to specify a rectangle, you need this coordinate x1, y1 and this coordinate x2, y2. Then you don't need these and these, since these will be here, x will remain same for this. So it will be x2 and y1. So you only need first and last. So height will be this one, difference of y coordinates. Width will be difference of x coordinates. So the list will be given in this form. So each rectangle is represented by 4 points, x1, y1, x2, y2, and they are non-overlapping. So next integral point will be here, or you can say first on this axis, all the points, then come to the next one level up, and here take these integral points. And what we have to do, we have to implement a function called pick. So when we call pick, it should pick one of the points. So all the points contained within this rectangle, this rectangle, this rectangle, one of those points, and each point should have equal probability of getting picked. So the distribution should be uniform. So let's see an example, then we will see how we can approach this problem. So let's say this is the problem. So this solution is nothing but the class constructor. So here we will just do initialization. So you see it's not returning anything. This is the output, and these two are the inputs. So it does not return anything, it just initializes the things, and it will contain a list of rectangles. So this part. So here you can see two rectangles. This is the first rectangle. So let's draw it. So it's -2, -2, x1, y1, that is this point. Then -1, -1, which is this point, assuming this is the 0, 0 origin. So what is the rectangle? This one. So this is first rectangle. -2, -2, -1, -1. And the second rectangle is this one, 1, 0, 3, 0. So 1, 0 and 3, 0. Maybe 2 is here, 3 is. So you see in this both points are lying on the same line. So its area is 0, but it covers 3 points. One is this 1, 0, then 2, 0, 3, 0. So we have two rectangles. Now in total, how many points we have? Let's draw this. So this is 1 point, and this width is 1. So this is second point, third point, fourth point, fifth, sixth, 7. So in total we have 7 points. So whenever we call pick, it should pick one of these. So let's list down the points. We have -2, -2, -1, -1, then -2. This is -2, and y is -1, and this point would be -1, -2. So these are 4 points of this. Then we have 1, 0, 2, 0 and 3, 0. So first time we call pick, it picked -1, -2. You can see this point. Next time it picked 2, 0. Although it's not in your control, this output may vary depending on the random function. Then -2, -1. So it has to return one of these points only, and it can repeat also sometimes. So what can be the straightaway very trivial solution that may come to your mind? So what you can do, you can iterate through all the rectangles. So this rect is nothing but a vector of 4 points, x1, y1, x2, y2. So you iterate through the list of rects, all the rectangles, and you run a loop from this point till this point. And you increment x. In the first loop you will have for x equal to whatever is x1 till x2, and y equal to y1 to y2, and all these points, and we will increment them, each of them by 1. So this is it, 2 loops, and we will cover each point and put each point in some list. So we will populate the 4 points, then append the remaining 3 points from second rectangle, and then we know that the size of this rectangle is 7. So just call rand function. It will give one of the 7 outputs from 0 to 6 in C++. If you are using Python, you can specify the exact range. and whatever is the index that we get, return that point. But you see that this will work, but here we are using lots of space. So the space used is of the order of number of points. And this is a pretty easy solution and it should be easy to understand. Only problem with this is that the space we have used is of the order of number of points. What will be the time complexity of pick? So pick we will call rand function, that will be constant time, and then based on the index we return this value. So pick function will be O of 1, but we are using too much space, and if we have a big rectangle, this was 1 cross 1 rectangle, but let's say we have 10 cross 10 rectangle, and there can be many of these rectangles. So how many points we will have? We will have 10 plus 1 multiplied by 10 plus 1, that is 121 points. And this is also not a very big rectangle, and it has 121 points. And remember, and if we have multiple of these, this list can grow really big. So we will do it in a slightly smarter way, although we will lose out something on the time complexity, but let's see. So what we will do, let's say we have one rectangle here, one rectangle is here, one rectangle is here. So we are given 3 rectangles and we are given these coordinates x1, y1, x2, y2. So we can calculate the number of points in this one. Let's say here we have 8 points, here we have 12 points, and here we have 10 points in this rectangle. This we can easily calculate. Whatever is the width, this is width, this is height, this is width. So height plus 1 multiplied by width plus 1. So this extra 1 is coming because even if you have single point, it's 0 cross 0, but it's 1 point. If we have 1 cross 0, it's 2 points. If we have 1 cross 1, we have 4 points. So you always increment 1. And the reason is that if we have, let's say height is 1 or the height is h. So when height is 1, we have 2 points. When height is 0, we have 1 point. When height is 2, we have 3 points. So this is always, number of points along the height is always 1 more than height. And let's say we increment the width by 1. This was the earlier state. So we increment width by 1. So we will include this point, and this point. So whatever was a height plus 1, we incremented that by each increment in width. So that's why it's w plus 1, h plus 1. So this you can easily calculate from the input for each rectangle. So again, what we can do, we can iterate through the list of rectangles and keep calculating their number of points within them. So for rectangle at index 0, we have 8 points. Rectangle at index 1 has 12. At index 10, at index 2, we have 10 points. So we now know the total number of points. So while iterating, we will keep a total points variable and we will keep adding to them. So first time we will get 8, then we will add 12 to it, then we will add 10 to it. So we have 30 points. So now we know that we have to return one of the 30 points. So we will call rand. Let's say it gives me 15. It returns 15, this rand function. And let's say it's returning from 0 to 29. That is in total 30 points, one of the 30 indices. So if it returns 15, that means we have to return the 16th point. So while iterating through this list of rectangles, we will also build another variable, which will be cumulative sum till now. So till first rectangle, we have covered 8 points. So what we are trying to do, we have 30 points here. So let's arrange them on a single line, on a vector. And first 8 points belong to first rectangle, that is rectangle at index 0. Next 12 points should be rectangle at index 1. And the last 10 are for the third rectangle. So till this point we have 8 points. Till this point we have 20, 8 plus 12. And in the end we have total number, that is 30. So we have to return 16 points. So our first goal would be which rectangle this point belongs to. So this rand return 15, so it's 16 points. So we know that we will search for 16. So this is increasing order. Since we are taking cumulative sum, it can never decrease. So we have to do a binary search here, or you can do linear search also if you are okay with that, but it will take more time. So 16 points should belong in the second rectangle. So till here we have 8, till here we have 20. So it's between 8 and 20. So we know that it's in the second rectangle. So now we have picked the rectangle that I have to return this from this rectangle. Now which point we should return? It has 12 points. Which one we should return? So we know that the first point of this rectangle is the 9th point. So 9th point is the starting point. The starting point is 9th, and that point denotes this one. So we are populating the points in this order, let's say, considering the points in this order. This is first point, this is second point, third point. So all the points along this, then all the points in this. You can also take in this order, first point, second point, third point, but it makes it easier to visualize like this. This is first, second, third, fourth, fifth point, and so on in this way. So let's say it's 3 cross 4, so it will have 5 points here and 4 points here. 4 points here and 3 points here. So we have to return 16 points. So 9th is the first point. How further we should go? 9, 10, 11, 12, 13, 14, 15, 16. So we have to go 1, 2, 3, 4, 5, 6, 7, 8 steps. So 8th point in this rectangle. Now our problem has reduced to find the 8th point in this rectangle. So what we can do, we know that its width is W. So there would be W plus 1 points in the first row. So if this 8 is less than W plus 1, then it means it's this point. It's on this row. If it's more than W, then we will check in this. So clearly we are taking modulo. So 8 modulo W. W plus 1, since there are 1 more points. So let's say it returned 3. Then we got the height. So if it was perfectly divisible, then it will lie along this. So x we will know. But if there is a this modulo is 4, then that means this was completely covered, this was completely covered, and here we got to 4th point. So this x coordinate we can find by this, and y coordinate we can find by dividing it. So 8y, in one row we have, let's say, W points, W plus 1. So how much y we should increase? So y we will get by this, x we will get by this. So if you are facing any difficulty in understanding it, please pause it and try to understand why it's so, and how we reduced this problem to finding the 8th point in this rectangle. Now let's write the code for this. So we have this rects. So we will keep track of one num points, which is total number of points. And then we need the cumulative point till ith rectangle. So we can store that in a vector of ints, and its size will be same as this rects. So in the constructor, let's initialize it, num points to 0. And let's store this rects we will need in this pick function also. So let's define this as the member of this. x1 is 0th point, so it's in this order, x1 y1 x2 y2. So this is 0 1 2 3. So width is x2 minus x1, which is rect 0 1 2, rect 2 minus rect 0 plus 1 multiplied by rect 3 minus rect 1 plus 1. So this is the number of points in this rectangle. So we have added this count to the total number of points, and also rect cumulative count. So now we have this list. Now what we will do, we will call the rand function. So point index, what is the point number that we want to pick? We have this total number of points. We will pick one of these. So rand and tech modulo num pts. So it will return from 0 to num pts minus 1. We have the point index. Next task is to find which rectangle this belongs to. Remember, we arranged all the points on a line. So first 8 points belong to first rectangle, next 12 point belongs to this rectangle, and the rand gave us 15, that means 16 point, and we know that 16th point lies in this second rectangle. And then we calculated the first point is the 9th point because 8 are in the first one. So it starts from 9 and ends at 20. So we know that 16 lies in this. So difference is 16 minus 9. So that is 8th point in this rectangle. And then we calculated that x coordinate would be if that number modulo w is 0, then that means it lies here. If it's 1, if it's w minus 1, it will lie here, and so on. So you can do the calculation here. So that we will implement here. So we are using binary search. So left is 0, r is rects dot size minus 1. If mid is less than equal to point index, so why we are taking less than equal to, let's see, then L equal to mid plus 1. So why we are doing mid plus 1? So even in the case of less than, it's very clear. So the index at mid is less than the point index. So we have to look in the right part. It's strictly less, so plus 1. But why at equal to also we are doing plus 1? Because this rand will return from 0 to 29. So here 15 means, let's say it returned 8. That means we are looking at 9th point. And let's say mid was here. So 8 means 9th point. So if we are not incrementing, we can keep mid also. It should work, but we can strictly move one more. So if we are getting 8 here, that means for the 9th point, the index is 8. So we are doing plus 1 in that case also. Else r equal to mid. So now L will hold the rectangle index. So we have narrowed down our search. Now our goal is to find which point in this rectangle. So for this rectangle, x points, that is the 1 plus width, is this one. So this is the rectangle, and here the number of points on x-axis is rect 2 minus rect 0 plus 1, and similarly y points is rect 3 minus rect 1. So this we have calculated. Now we have to find what is the starting point, or let's first calculate how many points are there. Points in rect, that will be simply x PTS multiplied by y PTS. Same thing what we did here. And then the first point in this rectangle, let's call it PT start. So what will this return? This will return the last point index for this rectangle, and there are this many points. So this cumulative will return this point, the last point, and we know that there are 12 points in this rectangle. So if we subtract 12 from this, we reach the first point. So this is the starting point in this rectangle. Now offset, what's the offset? It's point index minus point start. So we can simply return, we have to return a vector. So x coordinate will be rect 0, which is the bottommost leftmost point in that rectangle, plus offset, that is pt index minus pt start, it's pt idx, okay, and then modulo w, that was number of x points. So this is x coordinate, and what will be y coordinate? It will be dividing by xpts. So rect 1 plus, again offset, we can calculate it here. Let's keep it here. And let's see. Undeclared rect cumulative sum. It's cumulative count and not sum. And this works. You can get a different answer depending on the rand function. So let's submit if it's accepted. And the solution is accepted. So what is the time complexity here? For storing, we are clearly using this vector rect count, and this would be same as the number of rectangles. So time complexity is O of number of rectangles. Earlier it was in our this naive approach where we were storing every point, it was number of points. So this we have reduced to number of rectangles, which will be much less. For example, even in just one rectangle 10 cross 10 we have 121 points, and pick was O of 1, but here pick will be we will have to search for the rectangle index, that is the main time, and then finding the point from this is straight away O of 1. So here we applied binary search for finding the rectangle index. So time complexity for that is log of number of rectangles. So if number of rectangles is capital N, so time complexity is O of n, O of log n for pick, and space complexity is O of n. Now let's write the same thing in Python. It should be straightforward. And here we specify the indices. So we will specify self dot num pts -1 to keep it consistent with the C++ solution. So we have left some, it should be integer, and the Python solution is also accepted.